Welcome student to the series of lecture on LangGraph. And in this series of lecture on LangGraph, today we'll discuss one of the most important, or I would say one of the most relevant concept of LangGraph, that is long-term memory. The reason it is relevant and one of the most relevant uh, and needed conversation because today, if you want to build any agentic system and you want to interact with any agentic system, you want the system to be smart enough to understand the user, right? You want that interaction that if user come after a certain period of time, then the system knows the user, system knows how to behave with user, and system is aware about the preferences, the likes and dislike about the user. So that your agentic system can give a personalized, a customized experience to the user. Okay, so that's why we'll discuss long-term memory, which revolves around understanding the user. Till now, we have already discussed in LangGraph that there are two types of memory. The one is short-term memory, the second is long-term memory. And in the last session, we have completed short-term memory. What did we understand in short-term memory? We understood how to implement short-term memory with RAM and how to implement short-term memory with durable persistence. Now, exactly the same pattern, the same way we are going to implement in long-term memory. First, we'll implement the long-term memory with RAM for testing, and then we'll implement the long-term memory with durable persistence. So this is going to be the structure of the session in the long-term memory. First, we'll implement the long-term memory with RAM, and then we'll implement the long-term memory with the durable persistence. Now, some of you might say that long-term memory with RAM doesn't make sense, but it actually does. Because when you're building any system, you don't directly jump into a production level system. First, what you do, you test the system. You test whether your system behaves correctly. So the flow is step one, long-term memory with RAM. Step two, long-term memory with durable persistence, right? Because you want the system to be first tested. You want to understand whether the behavior of the system is as per the expectation in the testing environment. And that's what you're doing in the RAM environment or long-term memory with RAM. Okay, I'll just quickly recap why memory. When we studied short-term memory, the goal was very clear. When we studied short-term memory, the goal was very clear. The goal was to make the system understand the conversation. Okay, conversational memory. We discussed that LLMs are stateless, LLMs are memoryless. If the context is not passed, they forget everything. They will forget your name if the context window doesn't contain your name, right? So the short-term memory, when you implement the short-term memory, it will help in maintaining the conversational continuity. Okay, the user will feel that, okay, LLM is understanding my conversation. And short-term memory makes your responses, the system responses, context aware within a session, within a thread. Now the shift is to the long-term memory. Now the focus, the goal, the aspiration has changed. Now the focus completely changes, and long-term memory is about understanding the user. It is not about understanding the conversation. It is about understanding the user, understanding the user, understanding the user. That's it. Understand your user. Not the chat, not the session, not the thread. Understand your user. That is what you're implementing in your agentic AI system. Okay. And this is a much difficult, a much deeper problem to be solved. It's not easy. It's difficult. And you will understand the problems and the challenges in a while. At least the intuition you will understand. And when you will actually implement, you will see, oh, it's really, really difficult to tackle. Now, what are the problem? The problem is, take an example to understand the problem. Think about an agentic AI system with which you interact. Example, ChatGPT. How you interact with ChatGPT? In one of the chat, you discuss about your software preferences. I like Python. In another chat, you discuss about your travel preferences or travel plans. In the next conversation or in another chat room with ChatGPT, you will discuss about your philosophy. You'll open a chat and will discuss about some deep thoughts about philosophy and religion. In another, you will talk about your goals and aspiration. Now observe something very carefully. This will lead to a lot of problem. Problem number one, scattered information. What scattered information? All your data is distributed among or across multiple chats, never available in one place. So the first problem is how do we collate? How do we collate user level information from different conversation or different thread or different chat. What is problem number two? Now, this is not a bigger problem to solve, but later on, you will start thinking about it when you implement agentic system, but definitely you will face this problem. Even if we collect everything, not everything is useful in a chat. Not everything should be stored for that reason. Because a user might be discussing some random thought that is not about user, it is just one random thought about one random topic. How should you decide, or how do we decide what is important enough to store or remember about the user? How would you know that this is one streak of thought that is not related to the identity of the user? A difficult problem. Think about it. Problem number three. Now assume you successfully stored relevant information. Okay. And now in a new conversation, think about this problem statement and then you will understand the complexity of this problem. In a conversation, you start discussing travel to a specific city. Now, your preference for that city were discussed earlier. Okay. So it is stored somewhere. Now, the challenge is how does the system fetch only the relevant memory associated to that city instead of dumping everything in this conversation? I'm having a conversation, a new conversation about a city today, and I discussed about my preferences about that city in some another chat, right? I also discussed about the historical significance of that city in some another chat. Maybe the city is Jaipur. I talked about the historical information and I talked about my preference about that city. And I'm discussing about my travel plan. Which information, as an intelligent system, you will fetch? You will only fetch the information which is related to the travel preference, not the history of the city, right? So when you are trying to retrieve the information, the system should be smarter enough to retrieve the only relevant information. So therefore, it is pointing towards what? Semantic search. What? Semantic search. So we'll study semantic search. And we also need semantic search for semantic retrieval. We also need semantic filtering, right? So we'll discuss about that. Understand what we are trying to build. The goal, the goal here is to build a system that delivers personalized and customized responses based on user preference, user thinking pattern, user behavior, and based on user past interaction and relevant past interaction. Okay. So the system must store relevant information, must retrieve a relevant information or context specific information, and it should ignore irrelevant noises. Right. So, for example, if I'm discussing with ChatGPT about my travel plan in Jaipur, and it started talking about history of Jaipur, it would sound idiotic, right? The experience would be quite chaotic. Okay. So now think carefully. This cannot be a random storage. You cannot dump full conversation. You cannot have a blind retrieval. You need a proper system that understand what to store, how to store, structure of storing, how to retrieve intelligently. In other words, you need structured implementation for memory. And LangGraph solve this, provide exactly this abstraction through a core class, which is an abstract class that is BaseStore. It defines how memory is stored, how memory is retrieved. Okay, so it has certain capability like get memory, fetch memory, search memory, delete memory, update memory. So think of it as the foundation of long-term memory system. Very critical. Base store class is the foundation of long-term memory system. Now, if you're using base store, so base store is an abstract class. It is an interface. You first understand base store is an abstract class. It is an interface. Real classes that we'll use while implementation is InMemoryStore class, or PostgresStore class, or SQLiteStore class, or Redis-based storage, right? Now, InMemoryStore, this is the actual class. which you will use if you want to implement long-term memory in RAM. If you want a durable persistence, you will use these classes. But understand these classes are built on BaseStore class. They will inherit BaseStore class to implement long-term memory with RAM and long-term memory with durable persistence. Okay. So we'll see in the next lecture that how the BaseStore class has been implemented. Okay. Now we have a clarity. We have a clarity that short-term memory understand the conversation, long-term memory understand the user. And to implement the long-term memory, we use BaseStore as a core abstraction class. We start our conversation in the next session with the implementation of long-term memory in RAM. And that's why you will use InMemoryStore class. Once we complete the understanding of long-term memory in RAM with InMemoryStore class, because it is also complex, it is also time-taking, then we'll move into how to implement long-term memory with durable persistence, like with the help of PostgresStore class. Okay. So in the next session, we will move from this concept of in-memory store class, base store class to actual implementation. Okay, we'll start with the simplest version, which is the long-term memory with RAM and actually long-term memory with in-memory store class, because that's how you will implement it in RAM. Okay, once we have understood this properly, we'll scale the problem and we'll try to understand that how we can have semantic searches in the next to next session. So in the next lecture, we'll go deep into base store class, in-memory store class. We'll see the actual code. We will see the actual implementation of these classes, and then we'll do our implementation for our use case. Okay. So what we'll understand in the next session? In the next session, we'll understand how it works internally, both the classes, base store class and in-memory store class. Then how to implement for our use case, as in how to use in-memory store class to implement the long-term memory with RAM. Okay. With that, I'll pause here. Thank you. Have a nice day.